Good morning, one and all present here. I am Apakrita Tayade, a PhD student in Mechanical Engineering Department from Indian Institute of Technology, IIT Bombay, India. So today I am here to present my work on design and development of dual point photoplethysmography device for assessing impact of diabetes in arterial stiffness, on arterial stiffness. So what is the motivation behind it? Globally, there are 46.3 crores cases of diabetes, and out of which 7.7 million crores cases are from India. Nearly about 2.5 crore cases are pre-diabetics, and more than 50% of the people are unaware about their diabetic status, which leads to the health complications like hypertension and diabetic foot. Diabetic foot is a condition which happens over a time, and because high blood sugar damages the nerves and blood vessels, leading to the foot ulcers and further leading to the amputation. Globally, it is estimated that for every 30 seconds, a limb is lost to a diabetes. And India, the amputation rate is as high as 1 lakh legs are amputated annually. But 75% of these amputations can be prevented by early detection and prevention. So, peripheral arterial disease is a prevalent and a severe complication of a diabetes which leads to the diabetic foot ulcers. So, how PAD occurs when the plaque built up inside the arteries restricting its natural flow. So, because the arteries are narrowed, the body troubles getting the adequate amount of blood, oxygen and supply of nutrients to the lower limb. The plaque is a surface which is harder on the outside and the softer on the inside, which the hard surface can break and tear, forming a blood clots to form around the plaque, which narrows and thickens the arterial walls. Diabetes increases the formation of the plaque, hence increases the risk of peripheral arterial disease in diabetic patient. Hence, early detection of peripheral arterial disease is beneficial for preventing the diabetic foot ulcers. So scientists have supported the photoplethysmography as a non-invasive method for assessing arterial health. Photoplethysmography is an optical sensor which detects the changes in the blood volume. So the basic principle of the PPG is that the light attenuates when it's shown on the screen. The photo detector detects the changes in the blood and the tissue. It detects the changes in the light absorption, scattering and other factors in the blood and the tissue. The light attenuation varies depending on the blood volume entering the tissue under observation. So this is the basic PPG waveform characteristics which are shown. The PPG can be divided into two phases, that is a systolic phase and a diastolic phase. Systolic phase corresponds to the ventricular contraction, while the diastolic phase corresponds to the ventricular filling. A dichrotic notch is typically visible at the start of the diastolic phase. So for our study, we are going to measure the stiffness index, which can be computed using the path length divided by the delta t. So in our case, path length is proportional to the height of the person, and the delta t can be computed using the time difference between the systolic peak and the diastolic peak. So aim is to study the impact of diabetes on the arterial health. So for the same, the study utilized two PPG sensor which has to be put on the posterior tibial artery as shown in the figure. The posterior tibial artery is a critical site which is measured by clinicians commonly to assess the peripheral arterial disease. The sensor unit consisted of a optical sensor unit which has a LED and a photodetector, a microcontroller with AC to DC converter and a serial communication interface, D-latch to avoid interruptions in the communications, and a power supply unit. The study group studied were healthy and young subject below 40 years, age-matched control subject, AMC subject above 40 years, and diabetes patients subjects with more than 40 years. So for each category, we had 20 subjects. So the objective is to gauge the variation in the PPG characteristics for both the points along the same artery. So for the results, we can see that this is the graph for the 2-point waveforms for the point A and B for a healthy and a young person. we can see that there is a prominent systolic dicrotic notch and diastolic peaks are visible for a healthy and a young participant. Even though there is a variation in the size, the pattern remained consistent for both the waveforms. The table attached shows the delta T and the stiffness index value for both the points. Now in the second figure we can see that the graph is shown for the age match control, that is a healthy people above 40 years. So we can see that the less distinctive dicrotic notch is than the healthy and young person. Also we can see that there is a 66.55% increase from point A to B in the stiffness index value. The third graph shows the for the subject with a diabetes who is above 40 years. We can see that there is a different trend from point A to B in the waveform pattern compared to the healthy and AMC participant. Also there is an increase of 37% in the SI index from point A to B. So for the same from AMC and age match control, we can see there is an increase in the stiffness index value. With age, the vascular aging also happens. To counter that effect, we have taken these two groups and did their statistical analysis. So with the repeated ANOVA measures, we can see that the diabetes patients show a significant variation, statistically significant variation between the measurement points within the subject, whereas both the subject have a significant difference with the p-value of 0.013. So what we can say here is that the healthy participants, which are AMC subject, have shown a consistent pattern, whereas the statistically distinct variation was seen for the patients with diabetes. Also we can say that the higher stiffness index value were observed for the participants who are in diabetes category than the AMC people. This can be due to the increased plaque formation and the decreased elasticity of the walls, which increases the stiffness index. So in conclusion, the 2-point analysis of the pulse signals, we did in conclusion, I can say that the 2-point analysis of a pulse signals at different location along the same artery provided a valuable insight into the arterial health across different subject groups. Also, multi-point analysis captured the localized variation which may not have been apparent with a single point analysis. The study also emphasizes the significance of considering age and medical history, and also focuses on the multi-point analysis. The future scope is to make a compact model and assess the multi-point analysis with a larger population.